Thanks everyone for joining the Node.js Masterclass. Welcome Michael Dawson and Carlos Santana. Thank you for presenting.
Okay, thank you. So welcome to the Node.js Masterclass. Let me just there. So I'm going to start out a little bit about myself and Carlos, and then hopefully we'll have some information about the participants as well. I'm Michael Dawson, IBM's community lead for Node.js. What that means is I get to be a very active community member. I'm one of the collaborators, a member of the technical steering committee and community committee, currently acting as the TSC chair, and active in a large number of the different working groups, all of which gives me, a good insight into what's going on in the Node community itself, as well as, representing and working with the rest of the Node, the team we have within IBM focused on Node, as well as the other IBM teams to help sort of manage and guide our interaction in the Node community. Carlos?
Yes, my name is Carlos Santana, currently working in the IBM Garage in Solutions Engineering. But in the past, I've been involved a lot with JavaScript. My journey started with, I guess, Dojo and JavaScript and web pages. And since then, I've been working with Node.js in terms of tooling, mobile development, and recently doing a lot of Kubernetes, OpenShift, microservices with Node.js around serverless, service mesh, all that native stuff. Actually working with Michael on this reference architecture for Node.js.
Okay, thanks. So just to give you a little bit of an idea of what we'd like to go through at this point is to get a sense of where are the different participants, how they're using Node, are they using it in production? And I think we have a not too big a number, so I think we can go around that quickly. Maybe if you can put up your hand in the UI, there's a little hand button you can use to show that you're willing to do that, and then we'll use those to call on individuals to kind of just give a quick introduction. Your name, company, do you use Node in production? How do you use Node, and sort of what are your main interests of the things you want to discuss? Because I have it on the next slide, but we want to make this a very interactive session. We have a number of ideas of what we might talk about, but really we want to drive it based on what you're interested in listening in.
Also what you hate or love or think that Node.js should have, because Michael and myself and Joe are familiar with folks that work in open source. IBM is heavily invested in Node.js upstream, so we can take your feedback, right? That's what we do. We make things better by feedback.
All right, and Florin has their hand up and are unmuted.
Okay, well, great to be here. Great to go deep into Node.js. We're an IBM business partner called Helios Energia, based in the UK. And our role is to apply our expertise in innovation and solutions to basically use IBM products and services for clients. So we have a lot of pre-sales. We work a lot in demos, POCs, things like this. So I use a lot of cloud. So I have a lot of applications, Foundry applications running on the IBM cloud. And Node has been my preferred, operating environment. I love the asynchronous abilities of it, and I think it's a fantastic engine. So it ties into some of the things we're doing as well. I'm very interested in the Internet of Things, and so in terms of Node as being our server platform, I think we really want to go deep there and use it to create client solutions in hybrid integration and in containers and different ways.
Great, thank you. Ray Wilson, let me unmute you.
Hey, my name is Ray Wilson. I'm an ex-IBMer, actually. So if the name sounds familiar, yeah, you might know me. I work for the state of Minnesota now and in the operations group, and we use Node-RED to monitor around 800 servers and basically do statistics monitoring as far as traffic feeds go from an F5 and through data power. We also do health and well-being on the servers. It's basically our go-to alert system for we got a problem.
That's very nice to hear that. You said Node-RED?
Yep.
Okay, good. That's the first.
Oh, cool.
That's the first. Actually, that's the first.
Yeah,
Eric should be very happy to get this feedback. I know Eric. Excited.
Yep. And I've been doing Node.js for a while. I've written a couple of applications, but Node-RED just had a really nice interface for all the things we were doing with it.
Okay, and you keep all those logics in Git?
Yes, we have our own Git.
Okay.
And all the projects are checked in across the various environments. Each environment has its own pair of Node-RED instances. I've kind of cobbled together an HA solution using MQTT.
Okay, very well. MQTT.
Cool. Great. Yeah, thank you. I'll ask too if people can lower their hands once they've raised them and have had a chance to speak, and that might help me to go through full.
Like I think you can clear them. You have a eraser.
I don't see that, but that's okay. Victor, I unmuted you.
Yeah, hey everyone, Victor Leung here. I work for a little e-commerce startup called Merchant Spring. Also an ex-IBMer, used to be part of the IBM Cloud Garage in Melbourne. So look, we have a whole bunch of microservices running in Node.js at the moment. We are using that in production. We are running into some issues with, I guess, observability and manageability of those microservices. So we are probably on the verge of introducing some kind of service mesh on top of it. But that's pretty much it. I guess my main interest for today is just to understand the trends that and some of the problems that other people are also facing with regards to running Node.js in production. And, you know, I guess coming from a WebSphere kind of background as well, really missed the, you know, the ability to look really inside the process and see what's going on and stuff in real time. So if there's any tips and tricks you can share on that front, that'll be fantastic as well.
I took a note on that. Yeah, we can talk about that.
Great.
And you said service mesh, something about service mesh?
Yeah, so we're looking into things like SEO, for instance.
Okay, yep. I personally have done a lot of work lately on SEO.
Is anybody else interested in sharing their interest in what they're working on?
Yeah, I would like to hear like how you're using it. I know Red was a good one. Operations.
Excellent. Eugene? Yep, you're unmuted. We can't hear you, Eugene, if you're speaking. Well, I saw you mute and unmute, I think, but something's not coming through. You may want to check your audio toolbar in the top. There's speaker microphone test, and if you say that you can't hear it, then it gives you the option to choose a different input or output. While Eugene looks at that, anyone else want to share their usage? No? No one else?
Anyone doing ARM or IoT, putting Node.js in small devices, like a camera?
I'll unmute Florin. Florin, are you there?
You went in on a mute.
I wonder if we're having some audio difficulty here. It's two people in a row.
Yeah, and he was able to talk previously.
Yeah. That's peculiar. Anyone else want to try unmuting and speaking?
Were you talking about me? This is Dwight. I'm sorry.
Oh, yeah, there we go. Great. I'm glad we can hear you, Dwight.
Yeah, I'm sorry. I had to walk away for a second and missed you trying to call on me. So I am Dwight Bowman. I'm with the J-Hub Group and IBM Business Partner. And we don't use Node.js in production, but use it for a variety of pre-sales demo things. And I'm interested in learning more.
Cool. Florin, you want to try, or Eugene, anyone?
I think Eugene, maybe fighting with this audio mic.
Yeah.
Mic. Yeah, so we heard from people doing in operations. I think I heard MQTT, pre-sales, Foundry. Anyone doing Kubernetes or OpenShift? Any stories there being used there?
Let's see, Victor's saying he's done a proof of concept on Kubernetes. In the
POC
chat.
on Kubernetes, okay.
Cool. Well, maybe, I don't know if you have any more questions, feel free, but if not, then we can move on. And if Florin or Eugene, if you get your audio straightened out, maybe just give a shout, and we'd love to hear how you're using it as well. Arun, let's see. Let me try unmuting you. Can you speak?
Yeah, my name is. Are you able to hear me?
Yes.
Okay, my name is Arun. I work for a healthcare company called UPMC in Pittsburgh. We are an OpenShift customer, and we use Node.js for abstracting some of the infrastructure services. So that if the idea is like even if we switch something, so we don't want to redefine all those APIs, and it would be harder. So we have an abstraction, API abstraction that has been written in Node.js. We run that on OpenShift.
Okay, so you are providing an API adapter of a set to backend infrastructure.
Yes. For all some of the infrastructure services like networking, ITSM. So we are trying to do that, and we have done for a couple of them.
Very good.
Cool. Anything else? All right. Well, maybe we should move on.
I was hoping to hear somebody saying serverless. So it's in serverless in production. Go ahead, Michael.
Cool to hear about Eugene's work in the chat. Sorry, he was having trouble. They were having trouble with the audio.
So we can read it. A Permanente integration architect. We are using Node.js microservices for BFF on IBM Bluemix dedicated and migrating to IBM Cloud Public OpenShift. Yes. Okay. Yep. BFF is a good pattern. Go ahead.
I was going to say, Michael, we cannot hear you. I don't know if we lost your audio too now.
Does Michael?
Michael Dawson's having trouble with his audio.
Maybe we switch presenter and we switch back, or
yeah,
maybe take it from him.
Sure, we'll do.
Yeah, BFF is a good pattern. I don't know if you're doing GraphQL, but we personally we recently did an app. Actually, it's in GitHub. It's in GraphQL as a BFF in Node.js because the front end is React, and not because of React, but it's people that are not React were wanted a GraphQL API, so it was BFF, and then the BFF was calling just a Java Spring application in Java, just to showcase how to do a front end BFF with two languages. So BFF is a very good in terms of BFF pattern. Very common, I would say. If the front end is the web UI.
Yeah, for sure. Have you been, what sort of stuff have you been seeing with serverless in your experience?
In terms of serverless, I was the architect no longer, but I got that service out with OpenWith IBM Cloud Functions, and I would say 90% of all the traffic and all the action serverless are based on Node.js. Node.js is very, very popular in terms of for the folks using for serverless. It's easy to package into a zip file or your npm dependencies, and just upload a little zip file, and that's an action, that's a function. And also it's the integration with serverless framework, which is written in Node, and all the Node tools, npm install. It's easy to pick up in terms of tools. And in terms of container as a service in serverless, Node.js is a bit, when you are working or dealing with cold starts in serverless, you need a container. At the end of the day, all these things runs in containers. You need a container that starts very fast, so you want a programming language that starts very fast, compared maybe with a JVM. It takes a little bit longer, and that's why Red Hat started looking at Quarkus to make Java applications start very fast, so you don't have the cold start problem goes a little bit away. So that picking something that is script and fast to boot is very important in serverless. So that's something to take into account. And we're back in the main window.
Yeah, so I think Michael's going to drop and then rejoin, see if that sorts out his issue. So go ahead and do that, Michael. I'll watch for you to rejoin, and then I'll repromote you to presenter.
Oh, let me get to the chat. The chat is where.
Yeah, when you go from full screen.
And if you are, I don't think people can unmute. We try to let everyone unmute. But if you want to speak, go ahead and raise your hand, and Joe will unmute you.
Yep.
I can find this scrolling thing.
All right. Sorry for the delay, everyone. Michael will be rejoining momentarily, and then hopefully that will sort out his audio issues, and then we can continue along. But yeah, if anyone wants.
Yeah, right now there's no slides.
Yeah, because Michael
at the moment. Yep. And then last message is, my name is Tanya. I'm a manager for Go. We are using Node.js as a server to a React application. Application is in production. Yet I'm a rookie at this topic. Yeah, exactly. That's the pattern I was talking about. So Michael is back. Right.
Yes. Let's see if we can hear him.
Yeah, I had a presentation. If we needed to show slides, it's a presentation. There's a video recorded of me on Think sessions, and I go over like 3 best practices around containers, Kubernetes, and operations. Michael, you're back. Can we hear you? Should we call this one Murphy's Law? Got this one, Ross?
Michael, when you run the audio tests from the toolbar, does it?
Or maybe you can pass the ball to me, Joe, or we work with Michael. And we address a few things. So yeah, another thing that we can do is, if you can type in the chat, since everybody was able to find the chat, what are the type of things you are looking to learn in OpenShift, or maybe have questions Let me see if I can. Oh, Michael had it back. Michael stole the ball.
Yeah, I tried to give it to you. Oh, I think Michael even dropped.
Michael dropped.
There we go.
Let's see, this works. So let me bring the chat because now I will not see what people are asking for. So this is a presentation I did in terms of cloud native. This is a presentation. Can people see my screen?
Yes. I can at least.
Yes. So yeah, this is the garage. This is where we are working on. Some of these people are like not always laugh because these are not people that model. Those are people like actually I know. I work in the garage. We just happen to take pictures of them. So that's and that. In terms of containers, this is some of the best practices that we do for containers. Is everyone is familiar with containers in Node.js? Well, I want to talk about Node.js. This is Node.js. So in terms of best practices, it's always good to pick up an image that is backed by a organization that is keeping up to date with the security patches. A container that is written in a way that it is not running as root, and also keeps up with the LTS patch version of security. So that's always good to in terms of picking up base image for Node.js if you're creating a container for Node.js, or if you're dealing with probably build packs, for example, or if you're dealing with a serverless provider that is giving you a runtime. In terms of best practices for Docker, it's the ability to do the builds inside the Docker image or Docker file. In the past, maybe 2 years ago, Docker didn't have the ability to do multi-stage builds. In 2008, mid-2008, they provided the ability and all the container runtime, Putman or pick your favorite Docker container engine to build images. You have a build stage, so you can do the build inside the Docker image in a layer, and then copy files from it into the second layer or third layer, the last layer that becomes your final image. And that's much better than trying to compile outside. If you're working even for Java, it's like building the jar file outside and then bringing it in. It's better to have everything in a Docker file. And then the build cache to make it faster to build. And labels are something that we put in Docker files to annotate the images, to know that where that image came from, and the environment port is to expose. I didn't mention Docker ignore. So how many, let me see if we can press the green checks. A lot of people familiar with the .env file. .env is something that we use for development a lot, to load like the environment variable. Sometimes we put credentials there, maybe development credentials and things like that when you're working on. So I see people having Docker files that they would do copy everything from the root directory into the Docker image, and then that Docker image gets exposed. So guess what got copied over? Got the .env file got copied. So using a Docker ignore file, it's always good to ignore files that you really don't want to include, either for size or for security. So that's in terms of best practices for Node.js. Here's an example. If you want to take a look at an example of I don't know if a black background looks good or not. Is it okay?
Yeah, it looks okay on my screen.
Yeah, can you hear me now?
Yes.
Yes, we have Michael back.
Well, I dialed in on the phone anyway. Okay. Sorry. What's going?
Oh yeah, I was just talking about some best practices in terms of Node.js. There's a lot of best practices for other languages, but I sometimes for Node.js, people think, it's so easy that we don't have like even talk about it. And then you go to a field or do consultancy, and then like there's things that you can improve. And I think somebody mentioned going deeper into knowing what's happening inside the container. We can talk about how to use Prometheus to get information about how the memory is allocated inside, or even tracing. But I was just talking about the Docker file that using a multi-stage allows you to build a very small image, and in the first image to do a build. So in this case, it's a React application. So I'm building the React application in the first stage, and the things that I do is first copy only the package .json and the .log file, and then I run npm CI. I don't run npm install because I only want the versions that are in the log file. So the log file is something that should be checked into Git. And you can say that I'm wrong, but I think I'm right. So that locks down the. Go ahead.
I was going to say that's certainly an area where there's lots of divergent opinions, so that could be.
Yes. So when I'm doing my projects that don't cost money and if they don't have risk, that's okay. Do whatever you want. But then when you go into production, I like to know what's getting in that image and exactly the version and where it's coming from. So yeah, taking stuff from npm JavaScript registry might also be bad. So it's always good to have a staging server like Artifactory or Nexus. So what I was going to say was that the trick here is that you copy only the package log file. You don't copy all the files. You copy the minimum to make npm CI happy. And I use npm CI versus npm install. npm CI is much faster because it knows exactly what it's going to install. It's not going to do a dependency, resolving a dependency tree. It's just the things that are in the package log file. That's what I'm going to install. And I'm just going to download the TGS files. And then I copy the source code. And then I do a build of that React application into, into a build folder, but it can be any folder. The idea is if I make changes to my React application, I need to build the Docker image again. I don't have to wait 5 minutes for all this npm installation, npm CI. That is cached and never changes, so it just takes like less than a second to create a new Docker image by copying those files. And then the second phase will be, and those is to start from the base. I'm using the base, and then copy the React application that is built into the second layer or second image, the last image, and any files that were used for building, any source code, I don't need it. I don't need the React JavaScript. I just need the build, the compile application. I do the same thing again because I'm going to serve this through a Node.js server, or you can put in a CDN, but in this case, it's a server, a web server. So I'm going to do the same thing again, package log files only, and then in this time I do an npm CI, but for production. So I don't want any dependencies, dev dependencies. I only want like the production dependencies to make the image smaller. This is a trick or something that it needs to be always done for OpenShift. You're working with OpenShift. I don't know. We're working with OpenShift. The effective user ID that it runs is non-root. So it's a random ID, but the group is root. So any files that are needed by that process that you're going to read, write, execute, they need to be from the group root. So that's what I'm doing here, copying everything and then changing the group to the user, which is group 0. And then what I was going to say is I control the port number through an environment variable. In this case, operations need to change it. They can do it like that. And then I run the application. In this case, I'm using the node-mon to monitor the application and then run it. In this case, I'm using something called Scaffold, which is a tool that when you make it, you basically run scaffold def and it's watching files. So if I make a change to the application, let me show an example. Like, where's my server? Is my server.js? hello world. I can say hello world Node.js. It should detect the change of less than a second, and now it's already deployed in Kubernetes with a service running. I can do get service, and I have the external port because I'm using Minikube tunnel, but it's a load balancer, and I can do a curl against that IP address, and I get hello Node.js, and I can say the same thing again. Well, so fast Node.js that you can make a change, it automatically springs everything, and in my Kubernetes cluster, my changes are there, and if I want to debug, I can debug to it. So this was just an intro of maybe a workflow of when you're working with Kubernetes and containers is super fast to make a change and get something running in your browser. For example, yeah, this is the application running. I was doing hello, I think it was, yeah. And you can have like that live reload that happens in your laptop. You can also have it in Kubernetes, and this cluster can be in your laptop or anywhere. At the end of the day, you're building images in a best practice way that is optimized for this type of development workflow. So I'll end there, pause there, Michael.
Okay, so maybe if you can give me back sharing.
Yeah.
Okay, so let's see, share, come on. Again, so we'll go back to, we were just looking at, and we dove into one section there, but, you know, our approach is that we want to be as interactive as possible, build a list of topics that, you know, that you all want to cover. You know, we have a list of ones beyond Hello World that we think might be interesting, but we really want to build it based on what you'd find interesting. And, you know, depending on where we go from there, we have some backup slides, but I don't think we necessarily need to get there. The
or GitHub repos we can show, yeah, but it's what you want to discuss.
Yeah. So we have this possible list just to give some ideas. I'm thinking like if people could paste into the chat, you know, ones that look interesting to them, and we can start with that, and then, you know, maybe depending on the list that we get, if it's a long list, we can take a poll to see which ones we should dive into first. So if there's any, you know, any in particular, or, you know, that are on the list, or even, you know, not on this list that you think we should dive into, just add them to the chat at this point, and we'll start by building up that list hopefully together.
Monitoring, metrics, and tracing.
Okay.
Yay! Authorization and authentication authorization. Authentication authorization, auth. I want to make a comment about two interesting node modules. Okay, go ahead. Do we want to unmute Florin, or do you want to do it in the chat?
Well, let's put together this list. Yeah, like maybe.
Let's build a list, and then we'll hear from Florence. That's a good thing. So we have, I mean, everybody's looking at the chat. That's why we make it.
Health check, so database.
It's okay. Monitoring, metrics, tracing, authentication, authorization, which you get brownie points because you know the difference. And just about the two. Health checks. Oh yeah, health checks. We'll talk about that. Database, authentication, authorization, authentication. Database, if you can give more information about databases. The key topic databases. Could you please paste again here your GitHub project link? I don't know what that means. Web frameworks, testing, code quality. Web frameworks, testing, load balancing, and rollouts. Code quality. You can give a little bit more information about what you mean by code quality. You can talk about tools like SonarQube and code smells and linting and code coverage. Yes, I would like the GitHub also. Which GitHub that people are asking for?
Yeah, that I'm not sure.
Oh, maybe my little demo of think of
I think that's what I'm asking for.
using scaffold like live reload on using, yeah, it has 3 examples, containers, and it has the slides. Let me find it. I'll share it. And it has a Grafana, Prometheus, and logging also in there. There's that. What was the 3 examples? Operations. Yeah. Message queue. Yeah, somebody wants to make message queue, and there are tools that give a metric of quality. Yes. Well, actually, well, there's many. Codecov.io and SonarQube. We can show those. We can show the browser and talk about them. But SonarQube is it's one that we use in the garage for projects. I think it's okay. It's good. Give you code coverage, smells, lines that you covered, and we use it in the pipeline. So when the Node.js application is running through the CI/CD pipelines using Tekton, we just run the task against SonarQube, and the results are getting there. And we have a cloud native toolkit as a reference implementation that you can use and get it up and running in OpenShift.
So I can kind of.
I think that's it. I think we have the topics, Michael.
I can see from the list that we have here, I've written down like observability, and can cover monitoring metrics and so forth, health checks, authorization and authentication, databases, message queues, frameworks, testing and code quality, and then load balancing and rollout. It seemed that things around observability and authorization were fairly good. Were mentioned a few times. If you want to use the there's like a check mark in the beside your name that you can say. So would people be happy if we started out with observability and authorization authentication as the first 2 topics? And I guess check for yes and X for no, and if you don't put anything, then we'll soon find.
You're happy we'll be there.
Exactly, right. Okay, so I mostly see checks so far. So maybe we can start with observability. On that one, somebody had mentioned, they miss tools from, sort of their Java experience. And what I'd be interested is to hear, to start with, is like which ones are missed the most. Because as Carlos mentioned, we work in the community, and that would be good information for us to understand what people are missing in terms of what we can work on there. So are there, I guess in terms of the observability, if people can jump in, are there things I see, okay, so somebody has jumped in with JMX or real-time CPU and heat metrics. And I guess, whoever that is, Victor, do you want to unmute? You can... I guess maybe Victor's having trouble. Like I was just so that I was assuming that's like perhaps through an API to get that data while the application is running. On that one, I'd wondered if you'd already looked at things like Prometheus metrics. So the using Prometheus to generate and export that kind of data.
Yeah, you know what? You can share my repo, Michael. That one has some Prometheus demo, like the 6 examples one, and that will give you information.
yourself. Let's see. Can I? There, Victor, are you unmuted?
No, go ahead.
Yes, I am. Yes, I am.
Okay, there. Yeah.
So
sorry about that.
Yeah. No worries at all. So look, we've been obviously been able to get metrics at a container level.
Right.
So looking at memory usage and CPU at a container level, that's fantastic. But if we were looking at, say, a memory leak or something like that, being able to look into, at a process level, what the heap usage is within the process would be really useful. And I'm not exactly sure how to best do that.
Okay. So, I mean, that is something where, like, we currently, our suggested approach would be to use, like, there's Prom Client, which is a Prometheus, a Node Prometheus library, which you can install and use in your applications. And that will end up exporting things like, the heap usage and CPU usage that process is using.
Yeah, so there's a Prom client is one NPM module, and then that is compatible with another one. I'm trying to look at the name, but I have a repo that you can use to expose, and I have used that client in an engagement with I'll say the name of the company, but it's one of the largest car rental companies in the U.S. and we have problems with a Node.js application that was in development, and we used the Prom client to instrument that Node.js application to know how the memory was divided inside, to find that there were a memory leak and there was something in there. And also that was one approach. I think Michael was also involved with the same company in a second occasion, different application, and this time they did a dump of the Michael, you remember we did the dump, and then in the developer tools we loaded the flame graphs of the memory usage, and we were able to find that there was a particular object being increased and increased of that type, and we found that the line of code that for every request it was allocating the variable again and again, and we found the memory problem. So there's two ways to do it. One is Prom client can tell you the usage of that memory on the split, but then also the diagnostics of taking like a snapshot of with a debugger, attaching a debugger, and then looking at a dev tool of like what are the objects being allocated, and you can find the memory leak. I don't know if that's helpful.
Yeah, I guess Victor, in your situation, it's like Carlos was mentioning, the heap dumps are useful if you basically decided you have a leak and you want to try and figure out where that leak is, because it gives you some information on which objects are consuming the most memory in the heap after a collection, the relationship between those objects, what's keeping what alive. And on the other hand, something like Prom Client can help you export ongoing information about what the GC usage is, or that kind of stuff.
How much time you're spending in the GC? Yep. Then you're behind, and you can know like you're way behind. Your requests are taking so long to be processed because they're just sitting there because the time is stopped. But yeah, it can be instrumented, and you can do it live in containers, and for example in Kubernetes, instrument that.
The other thing I'd mention is one thing we did work in the community to get built in is, if you're coming from the Java world, you might be familiar with Java cores. And so we worked to get node or diagnostic reports as a built-in feature. So now you can take through a signal or through your code, there's an API where you can generate diagnostic reports as well. It's a JSON, fairly human-readable file. It'll include a snapshot of, what the sizes of your heaps are, some recent GC activity, information about what's going on in the libuv event loop, and even things like your environment variables, ulimits, things that may help you find like common misconfiguration or any of that kind of stuff. So I don't know, Victor, if we've covered off. Are there other things that are missing from what you you know, coming from the Java world that you'd like to figure out how to do with Node as well?
No, so look, I think you covered it. Just the Java calls in the heap dumps, I guess our typical tools. But thanks for that. That's very, very useful information. Thank you for sharing.
Okay, thanks. Anybody else have any things on the observability front that are pain points or? You know,
another one is distributed tracing. In terms of observability, there are three aspects, right? Monitoring, which we call it. Really don't call it monitoring, call it more metrics, right? You monitor on metrics. Tracing and logs. So for tracing, you're not familiar with, there's distributed tracing. There's a project called Open Tracing. There was one Open Census, and now two joined to create Open Telemetry. So if you go into the Open Telemetry Foundation, you'll find that. But the Open Tracing was started or associated more with Jaeger, which is another tool. So this will give you the ability to get traces inside your application. If you're doing a microservice that is handling HTTP requests and you have multiple containers talking to each other, then you want to find the bottleneck, or within one container you want to find how the life of the request. And if you're using Istio, it's even better. So looking at tools like Jaeger and distributed tracing is good. I can share another GitHub repo where I have simple examples to get started with Docker Compose to the level that you can have a distributed tracing lab with. I think I have both Java and Node.js using OpenShift and Istio working together to get a trace of what's really going on between the different Node.js containers, but also you can instrument it inside with Jaeger and OpenTrace inside your JavaScript container to know how the request is doing its job and who's the one taking the most time. Like, is it a call to the database, or is it processing something, and so on. So that's also another practice for observability.
I'd be interested through the check marks again, if people could, like, how many people have used distributed tracing in their applications so far? Yeah, again, check mark if yes and X if no.
Yeah, X no and green check. Okay. Yeah, it's another thing that I have used in production again with clients, enterprise clients that we have worked with a Kubernetes environment where we were trying to figure out how to meet a certain SLA, and we were not meeting it. We were meeting it when it was running on the developer's laptop. But at the request per second that we wanted to hit, the application wasn't meeting I think I remember it was 300 milliseconds, something like that. I was beyond that, the 90 percentile. So it's something that is not theory, it's actually used, and I have used it with Node.js.
Okay. Yeah, it seems like not too many people have used that.
So that, I think the problem, Michael, so we have to raise that in Java, I would say it's not easier, but there's a way of, as the single process is handling multiple concurring requests at the same time, it's easier to get a log, right? And a request ID, and then log, and then get how this application went from this point to this point. But with Node.js, you get into the point of adding, what's the module? There's a module that I cringe every time I see it.
Context local storage, I think. But
yeah, I cringe. I really don't like it because when it works, it's fine. The problem is when it doesn't work and it causes side effects. And so using something like Jaeger, you have to do a little bit more work, but at least you know how you can take one transaction and know visually, even visually nice, sort of like it took 100 milliseconds here in this function, and then 200 milliseconds in the next hop of another container and a different node, and so on and so on. And the whole transaction took, I don't know, 900 milliseconds. Right. And then you get your logs. And that's one way I was able to figure out some problems in production.
Yeah, I understand your concern over some of the modules out there for giving you continuous, like being able to stitch together the transaction across the asynchronous calls. The community is currently working on an API. There's a new API that was added and came out as experimental in Node 14, the asynchronous local storage. And it's intended to help address that problem in that it provides an in-core way to keep that context intact, which, as you mentioned, is much more difficult than it is in something like Java, where you can use existing capabilities in the C level, like for thread local storage. We don't have the equivalent because you're running on the same thread.
Yeah.
This is going to give you the same thing, and the goal is that since it's in core, it'll be easier to convince module owners that they need to do the bits on their side they need to do to keep the sort of asynchronous context whole and being passed across the right places.
Yeah.
Maybe at this point we should move on to the next topic. I think authorization and authentication. There's quite a few people who said that would be an interesting topic. If somebody who put that in, as a good topic, want to raise their hand, and we can get you to give us a little bit more of the context in which you're asking, that would be great.
Or which one?
Authorization and authentication.
Yep. And in IBM Cloud.
I'm going to just unmute him. Okay, so Florin, go ahead.
Florin should be unmuted.
Florin still there? I wonder maybe his hand was up from before. No. I guess anybody else who... Oh, wait a sec, Sylvain. Let me unmute Sylvain here.
Hi.
Sylvain,
you can hear me?
yes.
Yeah, okay, good. So I'm not a traditional Node.js expert at all. I come from more the IBM SAM, Access Management Authorization product suite. So I'm just curious to know do you have in Node.js? So what is there, native or not, or packages, or as far as authentication and authorization is concerned? Is there any mean, like in Spring Boot, to consume JOT assertions and the likes? So it's a very large question, but you can narrow it to a more fine-grained topic if you want.
Sure. So I know, Carlos, you looked at that a little bit in terms of some of the work we were doing. Do you want to talk to that one?
Yeah, well, the one that I'm most familiar is using JSON Web Tokens, that way of authentication. In Node.js, there's a NPM package called Passport. It's very, very popular to be able to inspect that JSON Web Token, also to generate the JSON Web Tokens. That's not a common practice to generate the token from the same server. Practice will be you look for a third-party authorization server. In this case, in IBM Cloud, we have AppID. So you use that as an authorization server. And then the client, when he's trying to reach you, you will say, you don't have a JSON Web Token, go away. And it will need to interact with the authorization server. It could be that login, could be an API key, it could be a username and password, it could be a social login. And then you get that JSON token, JSON Web Token back, and you return back to your web server application. And in that case, that's where you do your authorization. Like you inspect the token and see the claims and see if this user or whoever is calling me has, for example, a scope or a claim that says writer or admin. Then you allow him to do post or write to the database, things like that. Or if you're authorized, if the API is around reading, then you can expect more granular that authorization of it. So that there's NPM package that this is bread and butter, and it's easy to do to integrate this. And in IBM Cloud with AppID, we have some examples out of the box that you can get started to handle JSON Web Token inspected. Express is the one that comes a lot. That is the easier the one to integrate. I don't know. Yeah, I don't know if that helps in terms of that. The other aspect is that not people, I would say, if applications or products are getting more into leveraging a service mesh, this is where the point that you as a developer writing the Node.js code or the Java code, you do less. And like if you're required to provide HTTPS or SSL because you're HIPAA or GDPR, whatever is the requirement, then the service mesh is the one that takes care because it's proxies are put around you when you're in Kubernetes, and they handle that, and they can also handle the JSON Web Token checking, like checking that the request is good, that has a JSON Web Token that is signed by the authorization server, the public key, and then the request comes in, and then your code never has anything in it about checking the JSON Web Token. You can inspect the token and see like the identity, but other than that, it's handled by you. So I think that will be the two aspects of it, and then in general how it works. I don't know if that was helpful.
Oh yeah, yes, very much so. I'm happy to see that we don't give everything back control to the developer, so they can write their business code, and we can keep security and consumption of tokens in a separate fashion.
Yeah.
Thanks.
Yeah, and in service mesh or something like that, you will, for example, the scenario that I did about checking inside the Node.js server, you can put in the service mesh saying, if the request is a post against this endpoint, it needs to have this type of JSON Web Token. Or if it's a GET, then it needs to have this JSON Web Token, like handling. And then the developer just, in each method, assume that is by the time that it hits their server, is already handled. But that's my preferred way of handling before it gets to the business logic.
Lauren, I think you want to chime in? So Florina, I've unmuted you, but we can't hear you. Maybe, no, we can't. Okay, so please goes on. There was another question for Victor. Just, would you still have an API gateway in front of the service mesh?
Yes. The question that the second question that everybody asks about, like, if I have an API gateway, do I need a service mesh? If I have a service mesh, do I have an API gateway? And the easy answer is depends. But I would say yes, you will need an API gateway in terms of what you use it for. So what we have seen in the field, we're working with customers, they will have an API gateway that is their front, for example, API Connect or something that you're projecting APIs, handling API keys, maybe selling those APIs, tracking who's using those APIs, and that's kind of, I call it like the front door. And then the API gateway would put certain things in the HTTP header for then the service mesh to handle. And I think the confusing part comes, maybe it's from Istio, other service mesh. Istio has a component called the ingress gateway. And the name is like not meaning like it's an API gateway, but it's the entry point into the mesh inside the cluster of the microservices. So the API gateway can work with the service mesh, and we have seen that it works very well. If you have an API gateway to manage like who's consuming your APIs, that first stage of handling those APIs, and then that API gateway can actually put more metadata into the headers that then the gateway, the service mesh can handle it. That way you have more flexibility to, as you adopt service mesh and they get in this type of age, they're changing a lot very fast. You can change things fast but keeping your API gateway kind of static as you're servicing the API. So both can work together. I don't know if that helps.
And I guess like one of the takeaways there is Node isn't really any different from any other runtime.
Oh yeah, there's nothing related to Node. Yep.
Gateway up front using Istio as a service mesh, but there are components like the Passport npm component that was mentioned and that I pasted the link to, which will help you work with some of those technologies like JSON Web Tokens in Node.js.
Yep.
is there, before we move on to another one of the topics, is there any other questions or specific things that people want to ask about authorization authentication?
I think there was a question here, maybe related. It was Node.js in IBM Cloud Containers environments in terms of how to best authenticate, say, AI. I'm guessing like a Watson API service for apps. I think the granularity that Node gives you secure apps beyond the cloud protocols are currently in high demand. I'm not sure. I think this was Flooring also. If I cannot speak, what respect is that? But in terms of Node.js, Go, Java, like Michael said, authentication is authentication. So these APIs that we offer around AI, we have they're in IBM Cloud, or they can be in Cloud Paks in on-premise. The authentication is through AIM, and then you have an AIM token, and it's similar to the other cloud providers. You have an AIM key that then you have policies and access groups that you give access, and then you have the scopes. For example, in IBM, out of the box is like reader, writer, admin, manager, and then depending on the role, it depends what things you can do against that API. So, for example, you can have an AIM API key to provision a Watson API or a cloud service, or maybe changing it, and then you may have a different API key to just use it. And in that respect, if it's Go or Now or Node.js, you give the API key to that application, and then you would generate a token. And then your HTTP request, when you do HTTP request those APIs, Watson APIs, you just pass the JSON token that expires at a certain point, and then you have to refresh it. So that's the net of it, but nothing specific around Node.js, I would say.
Right. So there was one more question. You know, we mentioned Passport, which, you know, the question was, does that help with authorization? Because Passport seems to be focused on authentication as opposed to the authorization part. I don't know, Carlos, if you've come across any modules that help with the authorization. Like, I guess it would be implementing the, you know, roles or capabilities that you could provide versus just the, you know, do we know who the requester is?
Yeah, identity. Don't know from the top of my head. I usually don't work on that with abstraction. Just look at the JSON Web Token, look at the claims, and then depending on the claims, you either allow or not allow the request to go through, and then you send back your typical 403 HTTP. But yeah, when it comes to authorization, it's about business logic, right? Like people that are named Michael has a role of admin, and say Michael cannot write to the cars database in the DITR, but Michael can write to the motorcycles. So there's no module that can do that for me. That's business logic, right? I need to check if what's Michael's role. If he's the motorcycle manager, but he's not the car manager, so he's not allowed to talk to the database of cars, just motorcycles. So that's business logic they have to handle.
Right, okay. Any other questions?
Go back to other. There was a question about health checks. Two people put about health checks.
Yeah, so that was the next one I was going to move on. I thought we should move on. Yeah, so I think if there's no more on authentication, if people, let's just again do a poll. Is like, are people happy that we move on to health checks as the next one? Just again through the check marks or the X's.
Oh, sure. I think there was a question from Sylvia, or there was an old raise your hand. You're Sylvia, and you're unmuted. You have a question.
No, sorry, I'm just struggling and trying to lower my end.
Nope, there you go.
Okay, no problem. Okay.
Okay, so I just see a few people saying, yeah, that health check seems like the next good one, and no sort of complaints. So
I think that will be the last one, because we're up to 7. I don't want to keep people.
We still have an hour, so.
Oh, this is 2 hours? Okay.
Yeah. So yeah.
Oh, yeah, I can talk for 8 hours.
Yeah. Health checks. does somebody who put that on the list want to frame their questions? You know, what are their questions? What kind of questions they have about health checks? Just put up your hand if you were one of those people or are willing to frame your question. Guess I don't see anybody. I mean, we can talk about health checks, and I'm assuming people were talking about Kubernetes health checks, at least where it's fairly well defined with the, you know, the liveness and readiness endpoints. Maybe people. Okay, let's see. We've got a question here. For running a Node.js server in a Kubernetes container, doesn't IBM Cloud give you all the health and metrics?
Health and metrics. We can talk about this misconceptions on what is the responsibility of the cloud provider. There's a great chart, you know, you have it around. Like the more abstraction you go, more you delegate ownership to the cloud provider and less you own. So in Kubernetes container service, we have, I would say, two flavors. We have the IKS that we traditionally have, and now we have the new one, which is the OpenShift on Kubernetes. Both have the same SLAs. It's the same team manage it. We handle the master nodes. We make sure that we have an SLA of the SLAs. But when it comes to your application, inside your application, if you have errors and bugs and exceptions, there's nothing the provider can help you on that, right? So we are making sure that that VM doesn't go down, that the storage attached to that VM doesn't get detached, and that electricity and cooling keeps running. But what's the process that is running inside that container, your Node.js program, we're not responsible for. So that's where it comes to health checks of Kubernetes, where Kubernetes by default is trying to be helpful, that you can communicate with Kubernetes, and it has kind of a, back in the days, I don't know if it's still called watchdog or nanny, like it's watching if your web server or process is still healthy. That's called the liveness probe in Kubernetes, and that's a probe that you provide to Kubernetes saying, this is a way that you can check on me to see if I'm still healthy, and if I return a good return code is I'm still good. If not, just please restart me, and it would just kill your container and restart a new process. If you have the ability to kill yourself, that's my recommendation. Exit, and then Kubernetes will restart a new process with that container, and there's no problems with that. But if you have any situation that you don't own the code or there's any fork process or workers, then like there's three ways that you can tell Kubernetes or OpenShift, it's the same thing, to check on you. So one is could be a just a port check, and that's the one I usually recommend. Like if you're listening on port 3000 in a Node.js web server with Express, you can tell Kubernetes, if the port 3000 is open, I'm still alive and the application is still good. The other one is maybe you need to provide more information or check something, then it will be an endpoint like /live or /liveness. So port 3000 endpoint /live, for example, and then you will do some work to return back to 100. So, but take into account that it's a high-scale application that you have to squeeze all the performance and bandwidth. That's work that you're spending doing that versus doing processing a request. So we have seen corner cases that having an endpoint affects the performance of the Node.js application. So going back to just checking a port is good enough if you're not going to do that much logic inside that endpoint. And the other one is if you go ahead.
The HTTP check does let you validate a little bit more that your web server is up and running. So it kind of depends on which kind of risks you want to cover off. And I think the other thing you mentioned that's quite important to mention is that you do have to be careful with your liveness checks, that you don't end up in a situation where you continually cause your container to be restarted. So like don't be too aggressive in those checks, right? Because you can cause basically your container to be killed, but then while it's trying to start up, it takes more time and it ends up getting killed again before it can respond to you. Possibly because it's spending, a fair amount of startup CPU to get to the point where it could respond to that HTTP liveness endpoint. And so you want to sort of err on the don't check too often side versus like, oh yeah, let's just check every 5 seconds. No, you probably want to, be a little bit less aggressive to avoid those kinds of situations.
Another one is caching. I've done it in production where the liveness check is I'm doing a test of something like some fake transaction or talking to a downstream dependency. So if I'm talking to a Cloud and API, make sure the Cloud and API is okay. I'm calling a Redis, make sure the Redis is still okay. I'm doing like 3 HTTP calls or running through a one request, right? It could be you just exercising the function and then caching the result. So by the time the health check comes in, and the health check can come in from Kubernetes or it can come from something outside, right? It could be like New Relic just doing a ping health and you need to respond very fast. But if you are going to wait for the HTTP request or liveness request coming to start your health test, then you may take too long to respond back. So it's always another practice is you do the health check every often. So by the time the health check comes in, you already have the last result in. And in the next time that it comes in, maybe you have a problem and you will find that it's bad. But in terms of Kubernetes, what I've seen is the port is up or not. And then the other one is execution. Like sometimes you cannot access the port because maybe you're using Istio and it takes over the port. Just do an exec, so you can run like a script inside the container, or even a curl, right? You can do a curl localhost 8080, and that's one way of avoiding if your port 8080 on the outside is taken. And so those are like health checks that are before Kubernetes. You needed to do them in a like a black box way or like handle it outside. I would be selfish, and now if you're using Kubernetes, then you take advantage. Kubernetes is there to babysit and nanny your container, and if you make this your program stateless, it doesn't matter if it restarts; it just starts a new one, and Kubernetes knows that should not send traffic to it because it's not ready. So that will be the second check, the readiness. If your application, when it comes up, you can give it an endpoint, a health check called readiness probe, to check when is your application ready to receive that first traffic. And if your application is slow to come up and be ready, you may get HTTP requests that are like 500 an error. So then that's the point that you need that readiness check. I can share a link to a cloud native page that I used to teach that. Go ahead, Michael.
I was going to say we've had a fairly large, a good conversation across a number of different teams on the health and readiness endpoints, and I think there's discussion if you read the internet literature on the different endpoints about things you can do, like for example, in your liveness you can check more than just your own. Just returning whether your web server is up, you could check whether your database is up and so forth. But it's actually, in a number of those cases, you don't, just because your database is down, that doesn't mean you want to restart the process that the liveness is part of. So, I think we've come to the conclusion that you're better off keeping it as simple as possible. There may be some situations where, doing a more complicated check makes sense, but, you need to think through the scenario and make sure that restarting the container that the liveness check is on is actually going to help improve your situation. For example, in that database, killing the process that is talking to the database isn't necessarily going to bring the database back up. So you're just going to be, causing more CPU and problems than you are fixing. So, our sort of our current thinking is, absolutely, as Carlos says, use the liveness and readiness check in Kubernetes. It's built in. It's something, you can take advantage easily. To start with, keep it simple. Just, an HTTP or TCP type probe that responds okay. That will give you, a good level of coverage. And then if there's something much more, you know, if there's a specific reason why something more complicated makes sense, then, you know, obviously do that, but clearly think through that, you know, the container itself being restarted in the case of the liveness check, or not responding, you know, traffic not being directed to the container in terms of the readiness check actually helps solve the problem versus causing some additional problems.
Yeah, and this is, I guess you don't learn the first day, right? You learn this when you work in a production system. When you carry, I don't have my phone here. When you carry the pager duty, I carried the pager duty for a few years. And getting called during the night and weekends. So when you're building an application, you think about that you have one server and doing its work and it's in your laptop. But think about it, like Michael was saying, when you're deploying this Node.js application, you have 100 pods, like 100 containers. What is the usefulness of those containers every 10 seconds checking if the database, the same database, is up or not? You're wasting resources of having 100 Node.js containers, just spending, I don't know, half a second just checking if their down dependencies are, and all of them doing the same work. So if you really want to check on the database, then have a separate thing, right, that checks if the database for these 100 containers are up and down. You're using New Relic, or maybe you have another little container that checks all your dependencies, and you have Prometheus, and that will trigger a monitor or in sysdig, and then that will send you your pager duty in Slack or in the app. So you always, not always, but think about, like, you're building one container, but think about, like, this is when it gets deployed, it'll be 100 or 200 containers. And then I'm thinking on a scale, what could go wrong, or like what are you wasting in terms of when this thing scales?
So Victor asked a question here, which I'll read. How do you feel about external health checks? For example, from ALB versus health check directive in the Docker file. So what is ALB for my benefit?
Application load balancer?
Yeah.
Okay.
Or
got it.
in the context of what you were talking about, having health checks from Kubernetes, for instance. So external to the container versus in-container health checks.
Yeah. So based on my experience, I can tell you that I would, in production, have both. Because I have been burned that when I look at my Kubernetes server, my containers are up and their health and everything's green. And then on the other side, I have a customer sending me emails that they cannot access the application. And like, the application is up and he cannot access. From his laptop, when he connects, maybe the load balancer, or when I did the blue-green, I didn't switch it correctly. Or it could be my CDN, or it could be Cloudflare, right? Or it could be the application. Maybe the provider has a problem. IBM has a problem, and my container is still running, but the access to it doesn't. So if you are running an application that is like an application that has an SLA of 99.995 or 95, and is business critical that it cannot go down, then I will have both, and it should not. People should sleep better like that. I don't know if that resonates, but I've been burned. So having a probe on the outside that just checks that everything's okay, and then checking inside for fixing problems. So that's also in addition to that.
Makes sense. Thank you.
And I guess one extra thing I'll mention, and maybe we can move on to a different topic unless people have questions, is, you know, we did look at whether there were modules we might recommend or point people to in terms of health checks. And, you know, at this point, you know, with the advice to keep it simple to start with, you can add in Node. It's quite simple to add in an endpoint, like a liveness or readiness endpoint that returns 200 with a couple lines of code. Yeah. And so our current thought is, you know, just stick with that at this point. So any other questions or things on the health check side before we move to the next topic?
APMs, there's also APMs like what you call agents, right, that they are available from some commercial folks that are available in Node. I think New Relic has a good one. Dynatrace also has a few. Cloud Park for MCM has app metrics. So that's something that is also available that you can add as you build your container, put it inside, and that will communicate with the mothership, right? You send stats to it. But the ones that we mentioned before are more like cloud native, modern way of doing things, as people get more trained and know how to run the systems. So it depends on maturity and knowledge in respect.
Okay, so the next one on the list, I think, in terms of popularity was databases.
Yeah, I think
somebody want to sort of highlight what their question was in terms of databases?
Like dealing specific with a database from IBM using AIM, or maybe ways of authenticating with things like Cloud or NoSQL or MongoDB. I'm not sure what authentication databases mean. Who asked that? I think there was two people.
Yeah, there was one of the, a number of people just said database. I guess it's on our list of things, but it would kind of be.
Oh yeah, databases.
Or.
Which databases are better, Michael? NoSQL or SQL?
I don't think there's a one answer to that. It depends on what you're doing, of course. But and I'm not sure it's Node specific. I mean, I think Node is quite often used with NoSQL type databases. So there might be a little bit more of an affinity there, but there's certainly modules out there that will give you SQL, allow you to connect to SQL databases as well.
Yep. So, yep, that was a trick question. People have fun. I would say measure. I've seen where NoSQL databases, they don't give you the indexing that you expect when you start creating. I want to point out any NoSQL database out there, but some NoSQL databases, you will have performance problems when you get, maybe you use it wrong, maybe you need to scale it differently because the way that it does indexing or how many data you are putting at the same time, like records and records per second, and it's computing a view and an index, and it depends how you do your index and keys. It impacts the performance. It's talking from you have to do 100 millisecond transaction or 10 millisecond transaction, and the thing's taking 500 milliseconds. When there's load, and when there's no load, guess what? It's happy and dandy. Like it works fantastic. So maybe that's depending how you do your relationship or keys or indexes. Maybe a SQL database, relationship database might be better. And then you realize that. So if you know someone, then ask around or know their experiences and how the database is going to be used, what are the indexes, what is the load, how we're going to partition, how we're going to do the sharding, do the cap theorem, like what things is more important to you, if you're going to use a SaaS as a service or you're going to own it yourself. But I think none of these are related to Node.js, but at the same time are related to development and cloud native. I think that's what I have for Node.js.
I can't think of anything too specific to Node.js other than the Node.js, it's very easy to work with JSON, and that's a common format for data that's used with Node, and some of the NoSQL databases are also a good fit for storing JSON and retrieving it and finding data within it. But it comes back to like how you need to use that data and are transactions important and things like that. But that's the main thing that I could think of in terms of, a bit of an affinity for one versus the other. Otherwise, there will be libraries that let you connect to the databases. Some things that can be challenging sometimes is whether the database drivers are like native or pure JavaScript.
Yeah.
People do come across problems with, okay, a model which is quite common is that the database providers will give you native drivers, and they're performant and fast. So some of the modules may be wrappers that just wrap those native drivers. But unfortunately, that can result in the need to do compilation or installation of additional components in your environment versus a pure JavaScript driver. So that is something I think to look out for when you're choosing a client or figuring out the steps that you're going to need to make it workable when you're connecting to the database.
Yeah. 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 For Node.js, if you're a Node.js developer, or probably maybe you don't have a lot of experience in SQL, right? In SQL databases, and starting with something like MongoDB or Cloud Ant, where it provides an easy API and JSON is very good. And also GraphQL. If you're a fan of GraphQL, right? You abstract, you deal with GraphQL, and then let somebody else deal with GraphQL tokens to the database, the downstream APIs, and do the caching there. But in terms of Node.js, no, but yeah, I would say that if you want the performance, you have to use the native, performs better, but in terms of usability, UX, then you have to go to the trouble of compiling, making sure you have the right image, the right libraries for that library to run.
That is an area, though, where using containers does help a bit, because it's a little easier to put that environment together and get it into production versus having to, a non-container environment where you may have to do that separately.
Yeah, it's hard to think, right, that I don't know, 7 years ago, 8 years ago, we just deal with VMs and servers, and there was no containers. So it was like, pick the library because this libgc was going to be in the system, everybody's going to use it, or the OpenSSL library is going to be in the system, everybody's going to share it. And today, just containers, like it's just a CH root. Everybody can have their own version. It's reproducible. I can use that container in my laptop. It can run in my laptop. It can run in the cloud. It can run anywhere. It's the same package. So that has helped us a lot.
This is a good question. It says, and related to databases, how does Node.js handle the transaction management? I haven't actually been involved in a case where there was a transaction manager in Node itself. I don't know, Carlos, if you've come across that.
No.
I think it's the transaction. Typically, I think we would be relying on the database to provide the transactions if a number of things need to commit at the same time, or potentially microservices. Handling that in the background. I think that's an area where Node still probably has some work or patterns or things to be defined in terms of how you participate in a multi-phase transaction with commits and all that kind of stuff.
Yeah, I mean, looking at that in terms of transactions across services. And that's where I go async, using something like Kafka, and use a Saga pattern, and then let the system deal with the transaction and not holding that connection and the transaction then waiting. And that's sometimes that you have to think about, like if you're building multiple containers or multiple microservices talking between itself, do you go sync and do an HTTP call from one container to the other one, or just go async? And in Node.js, there's libraries and it's Node.js bindings for things like Kafka, and you just produce a message and then let the system consume the messages, and then you can do like a Saga pattern. That's been my experience in terms of transactions when it's across microservices. But in one-on-one, I haven't had experience with that.
That's not a bad segue to one of the next topics, unless there's something else somebody wants to bring up on databases, which is message queuing. So just before we move on, is there anything that anybody else wants to ask about the database side?
Is Redis a memcache database, Michael?
I'm not sure how I want to answer that. Like it's related. How about that? You want to talk a bit about those?
It's a data store, which is a very useful cloud DBs. I don't know what cloud DBs are. We're talking about cloud databases. But yeah, Redis is something that is used a lot. Trying to remember. I'll come to that. There was a recent story on a client engagement that the Redis example was using memory store. Wasn't using Redis. I think it was for a session and an app ID, and that's where you're going to bring Redis in. And these are like very fast, very small data that you want to coordinate and make available to all the containers, right? Or all the instances. It's not to store your business logic, but to make if somebody logs in, you don't want that person to log in every time, or they want a token, or you want a session. You want to keep some information cached and very fast available. So it's not a database, but I would consider it's a data store, fast data store. Somebody asked about Cloud DBs. I don't know what was the question.
Yeah, I clarified that. The question was, what about Cloud DBs? And it sounds like, for example, databases like the IBM Cloud for Progress SQL. So I think that, my understanding that would be basically, it's, maybe the same database, DB2 or Postgres, but it's hosted in the cloud versus running, an instance yourself, or even, spinning up your own container to host the database. I'm not sure there's anything too specific about Node in that context either. I think it's I see. So okay, so there's more context on-prem, but app in cloud. Right. So you're running your application locally, but you want to use the rest of the components from the services from the cloud. So your database is running in the cloud. I don't think there's anything necessarily specific to Node.
Yeah, we support. I mean, that if you want to talk, it's distinct, right? So it's IBM. Yeah, we're hybrid, so we support on-premise and hybrid, and we have ways of connecting VPCs, or if you're running Kubernetes, you can connect to a VPC. We support Direct Connect, that you can connect to on-premise things, and from on-premise you can connect to public cloud things, and you can have databases in the public, and you can have the database in the private, the application the same way, or two applications. So we're hybrid, and that should not change if you're using version of Node.js you're using. I don't know if that's familiar. Doesn't this take us to
Sylvain here, let me unmute Sylvain. Where is he in the list?
Many of the Scopers databases are legacy.
Oh, Sylvain, you are unmuted. I guess it's.
Yeah. I mean, I think you addressed it. I mean, I probably did not properly describe this, but let's say I have some on-prem workload, and I know it's not Node.js related, but is it a bad idea to have your on-prem Kubernetes cluster and your database in cloud? And what are the pitfalls? But if you feel it's a bit stretchy regarding this topic, I mean, we can skip, but do people do that because they want to get away with managing the DB and concentrate on-prem with their on-stack OpenShift technology, but they don't have the DBA resource available, so they just throw the database on cloud? So any thoughts around that, such pattern, bad idea, wrong idea?
Be careful about performance, right? If the database is like through wire next to it, maybe it takes 10 milliseconds, and then if now you have to go from this computer sitting on-premise to a cloud computer, then it may take 10 times that. Is your application okay with that? Then it's okay. But if your application needs to still be 10 milliseconds, it's going to be very hard if you move away the logic from the data. And that's kind of the basic principle when you separate things to be concerned. So you either need to cache or things like that, or replicate.
It really comes down to the query pattern, right? Like if it's less frequent large queries, it's probably less of a concern than if it's, you know, many queries. Then it's going to be how good is your connect to your on-prem to the cloud provider, right?
Okay, thanks.
Good question.
There was a question like, doesn't the asynchronous ability of Node.js address this problem of latency? Is that in the context of database? Hello?
Yeah. By Node.js being async, I think that async is a programming aspect. What we're talking latency is I send a request to the web server. How long does it take to travel back? So you can like do async inside the Node.js to take the next request, and all of them are like waiting on I/O, but that first request still waiting for my answer back, my 200 back. So that's what latency, the duration.
Right.
I don't know if that makes sense.
I think in my mind, though, there is something that relates here in that basically if you have a long latency and you're not async, that can cause you more grief than if you're async and have longer latency. So if in terms of your application, the latency doesn't cause you an issue, then the asynchronous nature can help you versus, you know, say Java, where your thread would be stuck waiting for the answer, and you can only have, you know, say 16, 32 threads servicing requests at the same time. So even if you don't need to get an answer back quickly, the fact that you're just waiting there means that you're going to stall other transactions or other requests, whereas in Node, because it's async, that won't be the case. It'll basically make the request however long it takes for it to come back. It doesn't matter because it goes on and it, you know, makes other requests and services those at the same time. And
it's better on I/O. So Michael, can I add like 10 more CPUs and make my Node.js faster?
Well, now that we have web worker support, you can do some of that, but you know, you can't just throw CPUs in an existing application that's running non-containerized. If you've written one so that you can actually deploy multiple instances of the container doing the work, then it actually gets a lot easier. So Kubernetes starts to help it make it easier. There was always ways in Node, things like the cluster module, and, you know, people often use things like Nginx to do load balancing. Yep. So that was really the way to scale in you know, CPU usage in Node was to scale across multiple instances, and with Kubernetes, that's making it even easier. But I will mention that workers now lets you start additional threads within the Node process. And so if you're in a case where you've got something that's particularly CPU computationally intensive, and you know the inter-process communication or synchronization between, you know, say multiple containers or multiple processes was going to cause you a lot of overhead, you do have that other option of using it in process as well.
Yeah. Yeah, and that was in 12, right? That was GA in Node.
I'm pretty sure, yeah. We're a little bit fluid because things get back-ported, but I believe it's GA is back as far as 12 at least.
But the thing is, I was half joking, right? Because just throwing CPUs doesn't make stuff faster, because if your application is not doing any math, right? It's just talking to a database to extract JSON or a file from cloud storage and then return it back to the little mobile browser that was requesting it. By having more CPU is not going to help you, right? This is it's not cranking numbers. So it depends on type of workload that your application is doing.
So I guess we were transitioning to the message queue topic. Does that sound good to everybody at this point?
Screen check if you want to move to message queues.
Red X if you want something else. Okay, so I see enough yeses. So let's move on to message queues. Again, I'll give the option of whoever had raised that as a good topic. Do you want to jump in and provide a little bit more context, or should we just jump into some discussion on that front? Just put up your hand if you want to add something or clarify the question there.
I think the something about message queues. Yeah, and Node.js. Any particular message queue or type of scenario or vendor or understanding Node is a single thread, and one of the ways to use message queues to support it. I don't quite get the question.
Yeah, well, here, do you want me to unmute you and you can, so there, I've unmuted you if you want to.
Oh, okay, so I think it's related to what you're talking about, Michael, multi-thread versus single thread. Maybe for folks maybe not familiar with Node.js, when we talk about that is single thread, it doesn't mean that it can just do take right the CPU. It's going to be in the CPU, but you can do multiple things, right? And there's async and async, and you create a stack, and eventually all those functions that you run eventually will get CPU time. I don't know if that clarifies the message.
Yeah, the async nature of Node lets you actually do more things at the same time than you could do with individual threads, because that single thread can have a lot of things going on at the same time. So for example, when you take an HTTP request, it actually takes your request. It may then farm off a bunch of requests to, say, the operating system or to external
network
microservices. And then it goes on there and says, okay, that's going to take some time. I'm going to go on to the next request. And it keeps doing that. So it queues up a whole bunch of work to be done. And when that work is done, it comes back to it. So for example, we hear people being able to have, say, 10,000 concurrent connections or requests with a single node server running in that, single threaded versus, some other application server type frameworks. You need one thread to serve each request, and therefore you're limited by the amount of concurrency you get. So Node actually gives you a very, very good level of concurrency, and the only thing where you can get into trouble is if you have something that's CPU intensive and it's actually going to take a long time to run because you're sharing that same thread across all those other things. If you're actually doing work that takes a long time, you're going to impact and delay how soon we can get back to the other work once it's finished. And that's where you start to look at farming things across multiple processes, or for example, you could use message queuing to say, I'm going to have a separate node instance. I'm going to have 10 listeners on that message queue, and each of them is only going to process one message at a time. And that makes sense if those messages will take like 100 milliseconds to run, or some larger amount of time, certainly if it's in like seconds or something like that.
Yeah. So if the application is not doing number crunching, right? I call it number crunching, like CPU intensive, then you're not doing work. It's just sleep, right? And it will come back when the I/O is finished. It could be I/O disk or I/O network, and then that you can accumulate. Like Michael said, you can have 10,000 things. But the work is just waiting, and so it can handle the next one and the next one and the next one. It depends on how many IO files you can have in the system. The file opens. I don't know.
Yeah, and the comment from the person who mentioned that was that they do have, when they have long processing, when they start to have longer processing, start to consider the message queues, and that is a good, kind of place. And Node is is a nice fit for the asynchronous model that you get with message queuing to start with. So the APIs and so forth are fairly natural.
But the clarification is, Michael, that if I have a request that comes in and I'm going to call, for example, another API, another Java, Node.js, not a HTTP request API, and that API takes 10 seconds. There's no point of me creating a message queue and put this in a queue, because that Node.js server is like, fine, if it takes 10 seconds, if I just take 6 seconds, it doesn't affect me just being waiting 10 seconds back from that other API. It could be the database, the Node Cloud database, or it could be the Watson API. I would not do message queue because it doesn't save me anything, because I can process the next request and the next request and the next request. So I would not be with that. What I would go with message queue is if the person that is calling me can wait 10 seconds. If the person that is calling me cannot wait 10 seconds for the answer, right? That's where I would, return back 201. Like, I got your request. Here's your ticket with a UUID that I generate, and then when that 10-second result comes back, I put it in a queue so somebody else down the line can send an email to that person or a mobile push notification to that person.
But it would be if you want to actually do something that takes 10 seconds of node processing.
Of what?
If you were going to write something that actually took 10 seconds of actual node computation, like...
Yes, if it's number crunching for 10 seconds, yes.
Then in that case, it would be another, reasonable way to say, okay, I know that if I do that in my main node thread loop, instead I can use message queuing to actually have multiple, node thread loops, as opposed to making a microservice call or something like that. That doesn't make sense.
Yeah, and this is a pattern that I really like, because I guess spend too much time in the serverless area working in IBM Cloud Functions, and this is what typically happens by design we make that when you call the serverless function, by design we make it at 1 minute, holding that connection live to force that async programming model where people upload a picture, and then I return back an ID, and that picture gets processed, puts in a bucket. So another function wakes up that detected that event, that picture was put in that bucket, maybe change the colors and put it in another bucket, cloud disorder bucket, and that wakes up something else, and then I send a message to Kafka, and then that something else wakes 3 functions, right? That sends a notification and an email. So this async programming model of constructing, composing functions is something that it works very well, and it scales because nobody's holding a connection. Like the last thing that you want to do is holding connections for a long time.
Right. I guess specific to Node and message queuing, that is another area where, like in terms of the Node clients, you can run into cases where there may be some highly performant. So, for example, for Kafka, there's a native library which is used by a number of the different language integrations, including one of the most popular Node libraries is native. Again, that can run into some of the compilation issues that you need to worry about. So that's something to keep in mind. Also, I think we've had people report issues where you can with message queuing operate in a sort of connect, make a request, disconnect type model. And that can make sense, I think, in cases where you're starting a process like a command line tool that will, connect, inject a request, and then stop, right? Or connect, get a request. But we have had some reports of applications which are long running doing the same thing, so that they're, maybe fairly high rate of requests, and that for every request they still connect and then disconnect, and that can actually cause a significant overhead. So in that case, it's better to, our recommendation is to, if you can hold on to the connection, keep it live, you're better off doing that, killing it and restarting every time. It may be a natural, if you've come from something that's like a command line type thing, that makes total sense, but if it's going to be longer running, avoid doing that, because that's something we have had
performance issues go away once you change that.
Yeah, and people will you have to realize that doing SSL, that first connection, right? It does a SSL handshaking and open a socket. So there's work invested in that first request when it comes in. But after that request, then everything should be streamed, right, to that same socket allocation. There's no SSL handling, so everything flows to that single connection. And going back to message queue, you mentioned Kafka. Kafka is a very good queuing system. Message produce consumers. You can have multiple consumers. Low balancing the consumption of the messages on a topic on a partition in IBM Cloud. It's called, the name of the we have Kafka as a service. It's called event streams. So if you go to the IBM catalog, you will find event streams. And then we have a free tier, and you can start with one topic. And if you want to get into learning how to do event-driven applications, event-driven architecture, event-driven applications where you have producers producing messages, and then you get a queue. It's events more than messages. We can get into messages versus events, but it's the same concept. It's async requests or async events that go into a topic in the partition, and you can have multiple consumers processing and handling the topics on that. And then you can start for free, which is very nice to learn if you want to learn about handling Kafka and the Node.js library. I think it's the RD Kafka, the one that we recommend. I need to find it out, but I'll post it in the chat. I think that was the last thing I had for message queue. If somebody had any other ideas, we cover it.
Yeah, just any other questions on message queues before we move on to the next topic? I think okay. So the next one, I think from the list, might be our last topic. There was a few questions that were related to code quality and testing. So we might choose that one. Does that sound good to everybody? Okay, I saw at least one check and no X's. So let's jump into testing and code quality. That's a fairly broad area again, so I don't know if anybody on any of the participants want to, is there a particular area or a particular question or a particular thing they were struggling with on that front?
Yeah, it can be from the standards of how to code your application. I'm going to use 4 spaces versus 2 spaces. 2 spaces is the correct way, or semicolons versus not semicolons. Not semicolons is the correct way, right? It's just my opinions, and then you can have like something like standard JS, which I really love because like I don't have to think about it. To then have unit test, mocking with testing library you have, code coverage, smells, and then go scanning to scan like bad practices. I think that's the spectrum, right? So,
yeah, linters.
And having 100% code coverage is what makes every application the best application and perfect, right? That's the goal.
Which I don't think there's ever been one. So.
Yeah.
Right, like code coverage. Once you do that, and actually, one thing that has been going on in the community is that that V8, which we haven't mentioned yet, but is the JavaScript engine that powers Node and Chrome browser, and now the IE browser as well. They've been doing work to help support code coverage. So there is some built-in support for generating that code coverage. In the community, we run code coverage on our Node.js build. It's been very useful to us in finding additional tests we can add, additional areas that we can test. But as soon as you look at the data or even look at how it works, you realize that you're still only, the coverage tells you you've run some piece of code once, but it doesn't necessarily mean you've tried the, like all the different combinations of things that could be passed into your function and that you're going to get
So really, I guess you've tested that the code is run in one of the possible contexts that it could be run in, but there's usually way more than that. So I think, Carlos was just alluding to, it's a good thing to do, but it doesn't mean that you've really validated everything in your test,
Yeah, somebody asked about, I forgot to mention, I think somebody has their unmuted, so if you can mute them. Thank you.
Yeah.
Somebody mentioned contract testing also. I forgot about that. I'm pasting a link to the Cloud Native Toolkit.dev. That's a project that I work on the garage that we make public. And it's a reference implementation of a CI/CD pipeline that we use certain things. So for the Node.js examples that we have, we run a linter, then we run unit tests, and then we run code coverage using SonarQube, and then we use Pact to do contract testing. And it's a good practice that we use to check that APIs that you're calling are the APIs that you're getting, and there's a contract between for example, the Swagger API and the client, and you can do Pact testing, and at different levels you can decide to stop the CI/CD pipeline for quality checks or just do warnings, right, and continue. So that'll be the transition of how do you test, or where do you start testing? So starting from linting, unit tests, code coverage, Pact testing is one pattern that we have seen successfully done in the garage. So that's just one example. But Pact testing is very useful. If people are not familiar with, encourage you to take a look.
I think otherwise there are some in the Node community, a number of good test frameworks like Mocha, and
Jest.
Jest is another popular one.
I'm a fan of Jest.
I think it
there's
depends
good mocking libraries also. There's very good mocking. Like Node.js has seen there's a lot of good tools in terms of because it's so easy to spin up a web server, right? I do the mocking and turn it down and bring it up and turn it down. It doesn't cost that much to do a web server versus other languages. It takes like a minute to bring up a web server. But it's like you don't even notice. It feels like unit tests to bring up a web server and do some testing. So any particular question about testing or Pact testing? I added the link. We use Pact, the Pact overview and the contract testing, consumer-driven testing as a resource there. Deployment in a non-containerized environment will be interesting, like round loop, client, or PM to, and that's related to the testing.
Yeah, I think otherwise we're pretty much at time. So, I think it's probably the right time to thank everybody for coming. And I guess there's one last question here. Can you share any guidance on API versioning? Would you only contract test the latest version, or would you run regression on older versions too?
That depends. That depends how to use that. If that's in production, you do test, and that's my number one rule. If it's used, there's a consumer using it. You need to test that it's backwards compatibility and follow semantic versioning as much as possible, right? Be a good citizen. If you want to go a little bit on the edge, put versions on headers and not URIs. The same. Some people think that that's a good practice. I'm not an expert in that, but yeah, one thing I would say, like service mesh, not to service mesh, but in terms of versions and canary deployments and V1 versus V2 is easier to do in service mesh because you have the capability of having two versions of the workloads deployed at the same time, and you don't have to have the same capacity on both. You can do maybe a percentage, like 10% of the users you send them to the V2 or V3 and then you start monitoring the testing until everybody's on that version. But before that shift left, you already tested the contract of the API, so I think it would not be applicable, even in terms of Knative, where you have revisions, that spin up on demand, auto-scaling. You have different versions of the API, but that doesn't save you from doing quality and gates, even shift left. So you always have to do it if it's being used.
Yeah, I think that for me it would be if you still have people using the APIs and you're changing something behind them, you should be testing.
What's that question? Oh, yeah, it's gonna be funny. Like, there's two ways that people version APIs that I know about. Some people like to put like the V1 or V2 in the URI, like my API / V1 get cars, like cars. And some other folks don't like to put because they have proper ways of doing it. Also, you can debate either way. And some other folks just leave the URI intact, and the version is in the header. So the client needs to read the request the API, and then you get back like what are the versions available. You parse the headers, and you select, oh, looks like there's a V3 available, and then you send a request on the same URI. It doesn't change with asking for V3 that you're going to talk V3, and then you talk V3, you don't talk V1, and all this happening through headers versus using the URI. So I don't know if that explains.
Okay.
Our developer use it in the URI. Should I hit them?
I think Carlos said it's okay either way, right?
Yeah, it's okay. It's okay either way. As long as you test it and then you advertise it, okay.
I guess the question was: is there a best practice, or is it just that some people do it one way? It's just like the two.
Yeah, it depends on the architecture and the enterprise. Some enterprises already have standards that even if they want to change, they cannot, right? Because they have some legacy code, they have legacy clients, and it costs more to change the clients than updating the API. So it always depends on what is the ROI. But if you're going to start from scratch, and today I've seen most of the time like it's in the URI, but I could be wrong. But the one in the headers give you more flexibility, but then people say it's more obscure. So I think the answer is Carlos can never win. So don't follow his advice. So for the folks that are left, if you want to say goodbye or where you are from, what time it is, that's okay. If you like the session, that's okay. If you didn't like the session, I think that's okay. I think for me it's 8 p.m. here in the evening, and I had a good time. Good question. Thank you for interacting.
Yeah, thanks to everybody to come, the good questions, and I guess we hope to see you in some of our other sessions if you've registered for some of the labs or any of that kind of stuff. Okay, so at this point, we will close out. Talk to everybody some other time.